Hey guys, so this video is about circles, but with a stopover at the Pythagorean theorem and the distance formula. These are actually both formulas for circles. If we sort of change the lettering, they're all kind of tied together. So first, let me kind of remind you of the Pythagorean theorem. If we have a right triangle and A and B, a squared plus b squared makes c squared, which is the hypotenuse. And so this first example here, with the 3 and the 6, we're supposed to find c, so that's that side. So we're just going to go 3 squared plus 6 squared equals c squared. And that would be 9 plus 36 equals c squared, or 45 equals c squared. And then from there, we will square root both sides. And then, so that gets us c. And then this is a 9 times a 5. So then c is going to equal 3 root 5. Let's bring this down, equals c. The distance formula is actually the same thing as the Pythagorean theorem, but just in terms of ordered pairs. So what the x2 minus x1 does is finds the change in x. So this would be like, in this case I have it labeled b, but here like the change in x was 6. The y2 minus the y1 finds the change in y, so that would be like the 3. And then square root equals the distance between these 2 points, with a change in 3 this way and a change in 6 this way. So let me show an example with that. And actually, before I do the distance formula there's one more in between there, and that's graph these 2 points and then find the distance between them. So 2, -1, if x is -2, y is -1, that's right here, and then 4, 2, so when x is 4, y is 2. So we're looking for that distance right there. And the easiest way to do that is to just draw a triangle. And then count the boxes. So 1, 2, 3, 4, 5, 6. So that side is 6. And then over on this side, 1, 2, 3. So I can say 6 squared plus 3 squared equals this hypotenuse. And then it's the exact same problem as the one I just did. So it's just this time they gave us these ordered pair. If I do this as a distance formula, just to show that it's the same thing and just to show how it's working with the graph, but this would be the easiest way to do it. And then this, of course, comes out to 3 root 5 again, because it's the example I just did. With the distance formula, we do change in x, so 4 minus -2, and then plus the change in y, so 2 minus -1. And lots of negatives going on there, so you gotta be careful with our signs. But 4 minus -2 is really 4 plus 2, so that's 6 squared. And then 2 minus -1 is really 3 squared. Oops, I wrote cubed. And so you can see it's the same 6 and 3. If I keep going, there's that 36 plus 9 down to the 45, and then the same 3 root 5. Much easier if you can count boxes to count boxes, but you can see what the 4 minus 2 is doing, or 4 minus -2 is, it's getting me this distance. Likewise, the 2 minus -1 is giving me this distance. And so in this one, we're just given the ordered pair, so we wouldn't, if we didn't have a graph handy, then we would use distance formula. So to do that, we're just going to go change in x, so 4 minus 3 squared plus change in y, so 5 minus a -1. So 4 minus 3 would be 1 squared, plus that would be 6 squared. So the distance is root 36, and 1 would be 37. Okay, and then that gets us to circles. So our formula for circles are x minus h squared, y minus k squared equals r squared. And this HK, that's going to be the center, and I think I'm going to write that a little bit bigger up here. So x minus h squared y minus k squared equals r squared, just to make it a little bit easier to see on a smaller screen. So the HK, that's the center. So notice the formula's got minus signs. That means like if I put in a +2, it's going to show as a -2. If I put in a -2, it's going to show as a +2. So the center is going to be backwards what's showing in the formula. R is the radius, and this would be the square of it. So we'd have to take the root to get the radius. And I'll show you what all that looks like with some examples. But notice that this, if I took the square root of both sides, is basically, it's just the distance formula. And if you think about, if you had 2 points and there's some distance, if I fix one at the center and I let this other one swing through all the x and y's that make that possible, what you get is a circle. So if I let one of them be a fixed point, the HK, the center, and XY is everything that keeps it that radius, it just sweeps out a circle. So that's how the distance formula and circles are related. So the first question is find the equation of a circle centered at 0, 0 with a radius of √5. So we'll just plug in, this is our HK, so x minus 0 squared, y minus 0 squared equals √5 squared. So these zeros are just kind of nonsense, so we'll just write this as x squared plus y squared. So when you don't see an HK, that means it's centered at the origin. And that equals square root 5 squared, which would be 5. So that would be our equation. Number 5, find the equation of a circle centered at -2,5 with a radius of 3. So this will go x, and then it's minus -2 squared. And next one we'll just write this the short way, but I just want to show how the signs are flipping. And then y minus 5 squared equals 3 squared. So cleaning this up, x plus 2 squared, y minus 5 squared equals 9. And so that's how the equation will look. So notice I have a +2, -5 showing, but my center's at -2, +5. So you just have to be careful when you're going this way that you get the signs flipped. Okay, give the center, radius, and then sketch a graph. So there's no xy showing, so that means the center is at 0, 0. And the radius this time isn't very nice. Radius squared is 8. And so if I root both sides, then I get radius equals square root 8. And if you put that in a calculator, you'll find it's about 2.8. And then the way you graph these in XYZ is you click on your center, and then you measure out, I believe, to your radius. And I think this was fairly forgiving, and I just kind of took it out to about 2.8, and it took the answer. And so on paper, we would just measure 2.8, 2.8 each direction, and then attempt to draw a circle. It's a little easier on the computer. So same directions. So the center for this one is going to be +2, -3. And then the radius squared is 16, so the radius is going to be 4. And so then graphing that, we're going to go over 2 and down 3, and then the radius of 4, so I'm just going to count up 4, down 4, right and left. And then if I could draw a circle, it would go through those points. It's kind of about like that. Okay, number eight's got a little bit more going on. So this time we're going to have to use completing the square, because the form of a circle has this completed square in it, and this time we're not in the right form. So the x is fine. There's no kind of weird x terms floating around, so that just means my x coordinates can be 0. But with this y, what I need to do is go y squared minus 6y. And then just like we did back in, I think that's section 9.1, completing the square, we'll do half of 6 is 3 and squared is 9. And so we add a 9 to both sides. And what that lets us do then is x squared plus, I can factor this, y minus 3 quantity squared equals 16. And now I have it in the right form. So my center is going to be at 0, 3. and the radius is going to be 4. So 0, 3 for the center, and then up, down, and right, left, 4. So this is the same thing, but now there's x and y terms, so we're going to have to complete the square twice. So we can come down here so I have some more room. So first I'll write it x squared plus 2x. I'm going to leave myself room. And then plus y squared minus 4y. Leave myself some room, equals 4. So for x, I have 2. So half of 2 will be 1, and 1 squared makes 1. So that's from the x term. And then for y, half of 4 is 2, squared makes 4. And now I can complete the square in x and y. So x plus 1, quantity squared, plus y minus 2, quantity squared, equals 4, 4, and 1, so 9. So my center is going to be at -1, +2. And radius squared is 9, so radius is 3. So let's see, -1, +2 would be right there, and then up, down, left, and right, 3. Okay, so for number 10, we got the following circle passes through the origin, find the equation. And for this, we kind of have to assume the center is right there. And so if it passes through the origin, then that gives me a point xy, and I have the center right here. So I know HK is 3, 2. And then I have an xy at 0, 0. And so I can just use the equation of a circle and find the radius squared, and then that gives me my equation, because I already know h and k. So it goes x minus h, so 0 minus h, so 0 minus 3, basically just changing x, plus the change in y, so 0 minus 2, equals r squared. So that'll be -3 quantity squared is 9, plus -2 quantity squared. And I could also just draw in the triangles I'm saying here, looking at it. This is 3, this is 2. That probably would have been quicker and better. But I guess if they weren't nice numbers. So this would be 4 r squared. And so then that means 13 equals r squared. So my equation will be x minus 3 squared plus y minus 2 squared equals 13, because that's our r squared. So let's see, find the equation of a circle with the center at the origin, and it contains the point 4, -3. Okay, so centered at the origin, and then x is 4, y is -3. So if it contains that point, then that means that's the center. And then I think it would also contain here, here, and here, just to kind of help me get this thing drawn. And actually, let's find the radius, and that will really help me make it a better circle. So if we knew this point, we know we're going 4 this way, and we know we're going 3 that way. So this time I will just use the triangle, and then that's going to give me the hypotenuse, which is the radius in this case. So 4 squared plus 3 squared equals r squared. And that's 16 and 9, so 25 equals r squared, and 5 is r. So to finish drawing this, that makes it a little bit easier. Oops, that should be up one more. There we go. So it should look like that. Yep, find the equation, sorry. Should finish it. So x squared plus y squared equals 25. Number 12, find the equation of a circle with a center at 2, 1, and a y-intercept of 0, 1. Okay, so the center is at x is 2, y is 1, and an intercept of 0, 1. So right there I can read my radius is 2. And so that makes finding the equation pretty easy. So x minus 2 and then plus y minus 1 equals 2 squared, so 4. If I had to finish graphing, it would just be up, down, left, right, 2. So to find the equation of a circle with a center of 2, 5 passes through the point -1, 4. So there's an HK, there's an XY, and I can just do our x minus h squared, y minus k squared equals r squared. So x minus h would be -1 minus 2, and then y minus k, so that's going to be 4 minus 5 equals r squared. So that'll be -3 squared plus -1 squared equals r squared. So 9 plus 1 equals r squared, or r squared equals 10. So then my equation is just going to be x and then minus 2, and then y minus 5, and then 10 is the r squared, so I don't need to square it. Okay, and then these last, I think 5 are the ones that have you guys try. So center and radius, so center is going to be at 1, -4. And the radius on this one is going to be √5, because that's r squared. And √5 is about 2.2. So center at 1 and then -4 would be right there. And about 2.2 up, left, right, and down. Give the center and radius and sketch the graph. Okay, so x squared, we got to complete the square in y, so plus y squared minus 4y equals 5. Half of 4 is 2, and squared makes 4. So this will be x squared plus y minus 2 squared equals 9. So center is 0, 2, and radius is going to be 3. And then just our up, down, left, right. Oops. Okay, give the center and radius, sketch the graph. So this time I'm going to do x squared minus 4x and leave some space. Y squared minus 6y, leave some space, equals -4. So half of 4, so I do complete my square. Half of 4 is 2, squared makes 4. And then for y, oops, plus 4. Half of 6 makes 3, squared makes 9. So plus 9. And then with the completed squares, we got x minus 2 squared, y minus 3 squared. 4's cancel, makes 9. So center is at 2, 3, and radius is 3. So center is x is 2, y is 3, and then a radius of 3. Number 17, find the equation of a circle with the center at the origin, x-intercepts of 5 and -5. So if you think about what that would look like, if that's the origin and it has intercepts here and here, you know the radius is 5. So that makes this one really easy. X squared plus y squared equals 5 squared, or 25. And last one, find the equation of a circle with the center. So that's our HK. And at 4, -1 passes through the point 6, -5. So that's going to be an XY. So I'm just plugging into this again. So x minus h, 6 minus 4 squared. Y minus k, so minus 5 minus a -1, careful with those signs there, equals r squared, and that's what we're trying to work out. So this would be 2 squared plus negative 5 plus 1 would be negative 4 squared equals r squared. So that's 4 plus 16 makes r squared, where 20 equals r squared. So our equation would be x minus 4 plus y minus a negative 1, so we'll just do plus 1 equals 20, because that's our r squared.